You should have looked at 3.9, and it was all about the rate of change over an interval. So average rate of change over an interval. Really, what we need to do before we start doing our practice together is we need to refresh our memory of what on earth the formula even is. And this shouldn't be something that's brand spanking new, because I know a lot of you said right at the end of the year you did start talking about rate of change. So first of all, let's remind ourselves what the formula is for that. So Braden, what is the formula for rate of change? You said you don't remember it? Okay, yes, Mina? Okay, rise over run, but specifically, there's some things about x's and y's. Yes, Ella?
Y2 minus y1 over x2 minus x1.
Mm-hmm. So rise over run. This part we're looking at is not on that paper I just gave you. The paper is some practice problems we're about to do together. I'm just trying to recap some things that we should know before we jump into today's stuff. So that is the rate of change formula. That's something that you saw a little bit last year and you were supposed to try and refresh on last night. And we're going to use that formula to find rate of change given a bunch of different scenarios. So it might be 2 different points. It might be a table of values. It might be a graph. Or it might just be an equation with set domain values. We're going to look at how do we apply that to each different scenario. So the one thing we have to understand is not all functions are lines. So up to this point, before Algebra 1, most of what you've looked at is a line, and lines have constant rates of change. So they technically have a slope. But now that you're in here, we've started looking at other types of functions. We started looking at quadratics and absolute values. We started looking at square root functions. And these do not have a slope because they are not going by a constant rate of change. It's changing over time. It's not going at the same rate the whole time. So that's why you need to understand this concept of average rate of change over an interval, because they'll just give you like 2 spots, like 2 points, and you're going to try and find the rate of change just between those 2 points. It's not the same the whole time. That's why it's just called average rate of change. All right, so our first example you have on the paper I gave you today. If you don't have it, then you just forgot to grab it. It's up by the board in a basket, so make sure you have that. Everybody's good? Okay. All right, so from 2 points, we got to remember which of these in this ordered pair, Miss Tosh, from that first example, 1, 7, 2, -4, which of those values are our x values? Okay, so this we could call x1, this we could call x2. And then so that must mean that 7 and -4 are our y values. It truly doesn't matter which order that these were written in, as far as if they gave me the point 2, -4 before they gave me the point 1, 7, I would have came out with the same answer. So what does matter though is now that I have them labeled, I put them in the formula the correct way. So I know that the formula is y2, so -4, minus y1, which is 7, over x2, so that's 2, minus 1. So when I simplify this, I have to be very careful with these integers. -4 minus 7. Henry, what's that?
-11.
-11. And then on the bottom, 2 minus 1, well, that's just 1. So our final rate of change between these 2 points is -11. All right, once you finish that one, I want you to try the second example on your own. Since they are not whole numbers, you would probably need to utilize your calculator. So set it up, the y2 minus y1 over x2 minus x1, and simplify it as far as you can. right, so Jacob, help me set it up. What should I have had on top?
Negative 2.47 plus 1.82.
Okay, I'm not sure if the board might be a little fuzzy, but it's negative 2.97. Is that what you wrote down? Okay. Minus negative 1.82 over, what should be on the bottom, Jacob?
3.20 minus negative 0.5.
Okay. And so we recognize that double negative really are going to make those pluses. If we didn't remember that, our calculator would have taken care of it. What did we get on top?
Negative 1.15.
Okay. And on the bottom?
3.45.
Okay. And what did that reduce to?
Negative 1/3.
Negative 1/3. If you didn't leave it as a fraction and you came out with a decimal, it would have been negative 0.3 repeating. Those mean the same thing. Okay. All right, so before we move to the next piece, do I have any questions on from 2 points? That's like the easiest it's going to get. From there, they're going to take that concept and start embedding it into some different things. So you've got to understand that to do any of the other stuff. Okay. All right, so the next thing they're showing us is a table. And we have to kind of be careful here. These are two separate problems. If that's confusing to you, you can write an A and B, so you know these are two separate problems. So when I look at part A, and I have 1, 9, and I have those square brackets on there, have we ever written an ordered pair like that? No, so this is not an ordered pair. That's not what that is. Those are the x values that they want us to find the rate of change between. So 1 is really our x1, and 9 is really our x2. That's just interval notation for the domain of the interval they want us to find the rate of change between. So I have this table up here that will assist me in finding the entire ordered pair. So when our x1 is a 1, our y is 3. So the first actual ordered pair we have is 1, 3. When our x2 is 9, that's going to be this other ordered pair right here. So our other ordered pair is 9, 15.8. So once I understand that, it's really back to what we just did on the first examples. So let's see. Matthew, what should I set up the top like? What should be on top from those 2 points?
9, 15.8.
I'm saying if I do y2 minus y1 over x2 minus x1, what would be on top?
9 minus 15.8.
Well, that's the same point, sweetheart. That's an x and a y value in the same point. Yes, Ramy?
15.8 minus 3.
15.8 minus 3. Yeah, that's what I was trying to say. And then, Miss Bailey, what goes on the bottom?
9 minus 1.
Okay. So when we simplify this, 15.8 minus 3 leaves us with 12.8 over 9 minus 1 is 8. So let's see what we get from, I'm sorry? 1 4/5, or what else? What is that as a decimal? Okay. Everybody check my work. Is that what you got? 12.8 divided by 8? Let's make sure before we keep rolling. We're good? Okay. All right, so now I want you to try part B on your own. Recognize that 9, 12 is not an ordered pair, but it is a set of x values they're giving us that they want us to find the rate of change between those two x values. Part B. Just like I did part A, I want you to try part B. All right, Jacob, what did I first have to do? With
You have to put 12 minus 9.
Well, do I have my points yet? I need you to lead me through the whole thing. What did you do very first?
First you find the y value under 9, which would be 15.8.
Okay. And then, so I got my first pair is 9, comma 15.8.
You find the y value for 12, which would be 30.86.
Okay. So that's the other ordered pair. And then what'd you do from there, Jacob?
I put 12 minus 9 as my denominator,
Okay.
and then 30.86 minus 15.8 is my numerator.
Okay. And what'd you get on top from that?
I got 15.06
Okay. Over.
over 3,
And what did that come out to be?
5.02.
Okay. So as a fraction, what would that be?
5 and 2 hundredths.
Yeah, which reduces to, okay, any of these mean the same thing. Okay, so most of you probably gave it as a decimal. It's totally fine. All right, so if they give it to you and you specifically notice those are brackets around it and they're not a parentheses, then they're not saying that's an ordered pair. They're saying between these two x values, what is the rate of change? Okay.
So they never give us that y value?
They would have to specifically tell you. It's assumed that they're going to be focusing on the domain, just like yesterday when we were doing like what interval's increasing, where is it negative. Remember how we were mostly describing it based upon the domain? That's what's still happening. Yeah. Okay. So the next thing, if they give us a function, and again I see 0 and 6 are in these square brackets, they're not in a parentheses. I got to recognize that is just the interval they want us to focus on, so that is x1 and that is x2. Again, these are two separate problems. Don't think they're the same problem. So last time they gave us a table and we just used that information and looked at it and then found the y value. This time they didn't give us a table. So does anyone have any idea of how I could find the matching y values that are associated with those x values? Yes, ma'am?
Would you replace the x with y?
Yeah. Wait, with y? You mean with that value?
Well,
Okay, so we did this last week. We did function notation when they told me to find like f of 2 and I plugged it in for all the x's. This is just another way that that looks. These are the x's and they're wanting us to find what would y be when x is that value. So I take the function they give us and we're going to substitute everywhere the variable is. I'm going to plug in that x value. So if I try it for 0 first, I've got 0 squared minus 4 times 0 minus 12. And if I follow the order of operations, 0 squared is just 0, minus 4 times 0 is just 0, minus 12 is going to give us a negative 12. So my first ordered pair is 0, that was the input that we put in, and then negative 12 is the output that we got. Input, output, x and y.
and then you do it for 6.
Then we got to go back and we got to find out what is the other ordered pair, so we're going to plug in 6. So we've got 6 squared minus 4 times 6 minus 12. So 6 squared is 36, minus 4 times 6 is 24, minus 12. The answer would be 0. So our other ordered pair, when we put in 6, we got out a 0. Input, output. Inputs x, outputs y. So now I have two ordered pairs to find the rate of change between. So y2 minus y1, I'll have 0 minus negative 12 over x2 minus x1, 6 minus 0. That double negative, what does that make happen? Positive. So this is really a positive 12 over a positive 6. So our rate of change is a positive 2. Alright, so once you get that down, I want you to try the second one. Same process. You got to plug in the input, those x values they give us, to get the output, which would be your y values. And then once you have your two ordered pairs, you can find the rate of change between them. This is if there's no graph, there's no table, this is all you've got. Okay, so first we plugged in the -1. Will, what did you get for plugging in -1? What did you get? 17. Is that what you said? Okay, so let's go back and double check that. -1 squared would have been a +1. A -4 times a -1 would have been a +4. And then I have a -12. So that's really like 5 minus 12. What should that be? -7. Okay. So our first ordered pair is -1, -7. So the second one, we have 49 minus 28 minus 12. So what would that come out to give us? 9. Okay. So we had our other ordered pair 7, 9. Once we had our two ordered pairs, it's just back to what we've been doing. y2 minus y1, so 9 minus -7 over x2 minus x1, 7 minus -1. So those double negatives are really like pluses, so that's really a 16 over 8. So this one also came out to be a +2. Before we move from here, any questions? Any numbers? Didn't know why it came out to be that? Okay. All right, so on the bottom of this side, we have it from a graph. So the most important thing is that you understand what they're trying to ask you to do. So part A says find the average rate of change for the interval between 3 and 6. So if I look on my graph for where x is 3 and x is 6, they're specifically talking about those two ordered pairs. So I'm just trying to find the rate of change between the point 3, 3 and 6, 9. The next one's 6 and 9, so you're trying to find it between points B and C. So between 6, 9 and 9, 11.2. And the last one says between where x is 3 and x is 9. So that must be point A and point C. So that's going to be between the points 3, 3 and 9, 11.2. All right, so I'm going to give you a few minutes. I want you to try and find the rate of change for each of those intervals.
Trying to recognize the way they're saying it to understand what we're supposed to focus on.
Got all three? All right, Captain, what'd you get for the first one?
2.
Okay, so you had 9 minus 3 over 6 minus 3, which gave you 6 over 3, which is 2. Correct. All right. Sutherland, what'd you get for the second one? Oh, you're still going? Okay.
2.2 over 3.
Okay, did that reduce to anything else? What'd you get it as a decimal?
So 0.0.7.
0.713.
0.73 repeated.
Oh, okay, couldn't hear him. Sorry. All right, and the last one, we would have had 11.2 minus 3 over 9 minus 3. So, Miss Ava, what'd you get for that?
Got 2.2 over 6.
You got 2.2 over 6? Let me go. 11.2 minus 3 is 2.2?
Oh.
Okay, I just want to make sure I didn't do anything crazy. So let's see. Sneha, what'd you get for the last one? Okay. And what did that reduce to? 3, 6 repeating. So the first one was a nice clean answer, but the other two were repeating decimals, so we just make sure we write that line over the part that's repeating. All right, so any questions from those? Okay. All right, so we should be wrapping up on the back. So it says, suppose an object is thrown upward from an initial velocity of 48 feet per second from a height of 120 feet. The height of the object t seconds after it is thrown is given by that quadratic function. Part A, they want us to find the average velocity in the first 2 seconds after the object is thrown. Okay, so yes, Sutherland. Yeah, but I also gotta know what the beginning one was as well. So you got half of it. We need to recognize what it was at the start as well. So when time is 0, we got to figure out what the height would have been. And then when time was 2 seconds later, we got to figure out what the height would have been. Well, really, I could just go back to the problem and recognize what they're saying. What's the original height that it's thrown from? Okay, if I didn't recognize that, I could have plugged in 0 for every variable, and I still would have gotten 120. I still would have gotten that same answer. But now I need to find out what the height is 2 seconds later. So now, negative 16, I'm going to plug in 2 for the time everywhere, for t, so that we can find out what the height is 2 seconds later.
So you can't just multiply by 2 for that? Because it's just like 0 to 2. You can't just add 2.
Oh, you're talking about
like
that particular thing?
Add
Well, is this just a line?
no.
So that doesn't always work. Okay, so that's why we're saying like average rate of change over interval, because it isn't always necessarily going by this like constant rate. So sometimes it works, sometimes it doesn't. So let's be.
Like dropping.
So let's check this one out. Last time we did these, I recommended you just type in the entire thing at once, because so many of you were kind of messing up at the front there with order of operations. So let's practice making sure you can type that whole thing in at once in your calculator. Negative 16, then 2 squared. If you don't know how to square something, there's a little x squared button on there. Yes, sir?
So on the calculator, I did it and I've gotten negative 1024. That's wrong.
That is wrong. I'm not sure. Come show me what you typed in.
This calculator is broken.
No, let's see. All right, that's correct. Yeah, so y'all got negative 152, right? Okay. All right. This is why I said try and do it all at once. You did something like with the negatives out of order. So 2 seconds later was 152. So did that answer your question? Did it just double? Did it go from 120 to 240? No. So that's why we couldn't do that. So I said 240. Okay. No, sorry. So now I have 2 ordered pairs to find the rate of change between. I have 152 minus 120 over 2 minus 0. So the change in y, the change in height, what was that? What's 152 minus 120? Yes, sir?
32.
Okay. And then 2 minus 0 is just 2. So what does that come out to be? 16. So let's make sure that we're answering the exact question that's being asked. It says the average velocity, that's 16 feet per second. Okay, 16 feet per second. That's the velocity that it is at exactly 2 seconds after it has been thrown. Alright, so part B, find the average velocity between when time t is 2 and t is 4. So that's between 2 and 4 seconds. Luckily, we already have the height at 2 seconds, so we can just save ourselves some work there. We already know at 2 seconds it's 152. So now we need to find out at 4 seconds how much it is. So we've still got the same function. We're going to go and plug in 4 for time now. So we got negative 16 times 4 squared plus 48 times 4 plus 120. So practice putting it all in at once. 56. Let's get some confirmation. Let's let some other people. I think it does go down, but I want to see. Okay. So far, there's a claim of it being 56. Is that confirmed? I'm sorry? Crazy numbers? You typing it all in at once?
I got 56.
56 is the correct answer. What'd you get, Bailey? Okay, come show me what you're doing. So between those 2 points, I want you guys to try and find the rate of change. Okay. So I'm going to do it in parentheses here. Times 4 squared plus 48 times 4 plus 120. Okay. The way you were typing it was following like some order of operation incorrectly. All right, so when you find it, yes, sir?
Negative 64.
Okay, so when you did 56 minus 152 over 4 minus 2, you should have gotten a negative number. And he says it's negative 64. Is that confirmed? Okay, let's see. Let's see if you did the math right. 56 minus 152. What's that? 56 minus 152. Okay. 4 minus 2 is just 2. So whatever negative 96 divided by 2 is,
I got negative 48.
that should be right. So negative 48. Confirmed. I want to see a lot more yeses or nos. Okay. So negative 48, what's though? Feet per second. So later on when you get to physics, you're going to do a lot more with velocity. Speed can't be negative, but velocity can be. Because it's just going down. It's going the opposite direction. If you're going backwards or down from the start, it can be negative. Okay. All right, so from that, you had to recognize what you had to do with the information. This is what I'm saying. They're not just going to give you 2 ordered pairs and say, here, find the rate of change. You've got to interpret exactly what's going on. All right, so I think we are to our final example, ABCD. So the table below gives the velocity of a skydiver t seconds into free fall. We have our table. Part A says to find the average rate of change of velocity for each 10-second interval. Okay, so we're going to try, instead of writing them all out, we're going to try and be a little bit more efficient here. So we know every time it's just going up by tens. So these are our changes in x, technically. They're labeled t, but these are the x values. I'm going to write over here x, because that's really what time is. And the velocity is like our y. So we're going to find the changes over these intervals. Are you okay?
Yeah.
So it goes up 147. Then from 147 to 171, how much does it go up? Okay. And then from 171 to 175, how much does it go up? And then from 175 to 175.8, it's just 0.8. And then from 175.8 to 176, it's... And then, is there any change at the last part? No. So if these are really the changes in y, didn't mean to do that, and that's really the changes in x, we can just put over the changes in y over the changes in x. So the first one, what's 147 divided by 10? Okay. Then we've got 24 over 10. 2.4. Then we've got 4 over 10. Okay. Then we've got 0.8 over 10. Okay. Then we have 0.2 over 10. And then we have 0 over 10, which is just 0. Okay. So for each interval, it's clearly not the same rate of change. It's changing every time. Okay. All right, so we've done part A. Part B says, during which interval was the average rate of change the highest? Where's our rate of change the highest? So the first interval. So between 0 to 10 seconds, and I'm going to write it like that. You could have technically said 0 to 10 seconds. But remember, if I write it that way, I'm saying those are the x values or the input or the domain, any of those. So between 0 and 10. Use the average rate of change from 10 to 20 seconds to approximate the skydiver's velocity 15 seconds into it. Well, luckily we did all this work already. What was the average rate of change between 10 and 20 seconds?
24.
Oh, 24 over 10, so it was approximately 2.4. So clearly, it's not exactly 2.4 because they're saying at 15 seconds, but they asked us to use what we found between 10 and 20 seconds to approximate. And the last part, part D, use the average rate of change from 0 to 10 seconds to approximate the velocity 8 seconds into the free fall. So when we did from 0 to 10 seconds, what was our rate of change? So approximately,
Is that what that's doing?
yep, because if it's like this, it's exactly equal. If it's like this, it's like approximately. Kind of squiggly equal signs, basically. I'm sure there's a term for it. All right, so we've covered a bunch of different ways that you might be asked. At this time, once you get that example down, I want you to go ahead and open up your laptop and use your notes to help you on your independent practice. So this is something I want you to try on your own. You have an example of each type, and then there's one extra challenge question that is for 0 points. Okay, I'll be walking around to help you as you work.